Graph the following on the real number line. The first is absolute value of x is equal to 7. The second is absolute value of a is less than 5. And the third is absolute value of y is greater than or equal to 4. Okay, so let's start with the first one. So absolute value of x is equal to 7. And actually, before I start, let's recall the absolute value function, right? So the absolute value function says that absolute value of a variable x is equal to positive x if x was positive to begin with, so greater than or equal to 0, and it's equal to negative x if x is less than 0. So now considering the first one, absolute value of x is equal to 7 means that x is equal to 7, or x can be equal to negative 7, right? It's just the distance from the 0 point on the real number line. So graphing this on the real number line, let's say this is our 0, and then we have, 1, 2, 3, 4, 5, 6, 7. And then on the left we have 1, 2, 3, 4, 5, 6, negative 7. So drawing this, we know that x is equal to 7, or x is equal to negative 7. So that's how we would draw that. Well, that's how we would graph that, something like that, on the real number line. So that was part A. Part B, absolute value of a is less than 5. So now taking the same definition of the absolute value, we know that a is less than 5 or negative a is less than 5. So we have to consider both the cases where it's positive or where it's negative. So negative a is less than 5 if we divide both sides of the equation by negative 1, we get that a is greater than negative 5, right? Because whenever we divide or multiply an inequality by a negative number, it switches the signs. So in this case, we have that a is less than 5 or a is greater than negative 5. So let's graph that on the real number line. So we start with our 0 in the middle. We go out 5 spots. So we know that a is less than negative 5. So we want to draw an open circle on the 5, and we know that a is between these values here. But also, we know that a is greater than negative 5. So if we move 5 spaces out here to negative 5, we want to draw an open circle since a never reaches negative 5, so it's an open interval. And since a is greater than 5, well, negative 4 is greater than negative 5, and so is negative 3, so the line's going to go this way. So the values, such that absolute value of a is less than 5, comprises of the values between negative 5 and positive 5 on the real number line. Finally, part C is we want to evaluate y is greater than or equal to positive 4, right? Right. So using the same trick, we know that y is greater than or equal to 4, or negative y is greater than or equal to 4. And on the right side, again, what we want to do is divide by negative 1, which switches the sign. So we have y is less than or equal to negative 4. So in this case, we have y is greater than or equal to 4, or y is less than or equal to negative 4. So drawing our real number line again, put the 0 in the middle, and we have y is greater than or equal to 4. So since this is equal and this is going to be a closed interval, right? So y can be equal to 4, so it's just going to be a dot. And since y is also can take values greater than 4, it can be 5, 6, etc. So it can actually be any number on this part of the line here, right? And similarly, y is less than or equal to -4. So we go 4 out on the left, and y can be equal to -4, and it's also equal to numbers less than -4. So -5, -6, all the way out to -infinity. So this is the interval of the possible values that y can take on the real number line, and that was C.